Factored theorem by Hyson Dib. Welcome to my presentation on the factored theorem. In this presentation, we'll explore how the factored theorem helps us factorize polynomials and find the roots. We will cover its definition, applications, and examples to understand how it works. What is the factored theorem? The factored theorem states if a polynomial fx has a factor x minus c, then fc equals 0. Key concepts. This theorem connects the factors of a polynomial to its roots. Example, if x minus 2 is a factor of fx, then f2 equals 0. Another example, if x plus 1 is a factor of fx, then f minus 1 equals 0. How to use factor theorem. To check if check if x minus c is a factor of a polynomial of fx, substitute c into fx. If fc equals 0, then x minus c is a factor of fx. So if you substitute it in, work out the equation, and it equals 0, then we know it's a factor of fx. Let's look at some examples. Consider fx equals x to the power of 3 minus 4x to the power of 2 plus 3x minus 2. Check if x minus 1 is a factor. So we're going to substitute x equals 1. So f1 equals 1 to the power of 3 minus 4 1 and times 1 to the power of 2 plus 3 times 1 minus 2 equals 0. So x minus 1 is a factor because we solved out the equation, and at the end of the day, it equals 0. Factoring polynomials. If f minus c is a factor, we can divide the polynomials fx by x minus c to obtain the quotient polynomial. Now let's look at some examples. Given fx equals x to the power of 3 minus 4x to the power of 2 plus 3x minus 2, we know x minus 1 is a factor. Perform polynomial division to get the quotient. X to the power of 2 minus 3x plus 2. Now factor the quotient x to the power of 2 minus 3x plus 2 equals x minus 1, x minus 2. Hence, fx equals x minus 1 to the power of 2 and x minus 2. Algebraic properties. The factor theorem is closely related to the remainder theorem. If fx is divided by x minus c and remainder is 0, then x minus c is a factor. Because at the end of the day, if we do the solution and it equals 0, then we know it's a factor. If fx equals x to the power of 3 minus 5x plus 6, we divide by x minus 1. The remainder is 0, confirming x minus 1 is a factor. Once again, if it equals 0, then we know the solution, and it is a factor for the solution. Applications of factor theorem. Finding the roots. The factor theorem helps identify the roots of a polynomial equation by testing possible factors. Factorizing polynomials. It is it's a useful tool for simplifying polynomials by finding their factors. Solving equations. Once factors are found, they can be set equal to 0 and solve for the roots. Example problems. Factorize fx equals x to the power of 3 minus 3x to the power of 2 minus 4x plus 12 using factor theorem. First, test the possible rational roots using rational root theorem. Test x equals 2. So we're going to substitute x equals 2. f2 equals 0. So f minus 2 is a factor. Now divide fx by x minus 2 to get x to the power of 2 minus x minus 6. Now we're going to factor. Factor x to the power of 2 minus x minus 6 to get x minus 3 and x plus 2. So now we're in factored form. Then, so fx equals x minus 2, x minus 3, and x plus 2. And that's the final form we get to. Conclusion. In summary, we've learned how to apply the factor theorem to identify factors and solve polynomial equations. Now let's look at the key points of my presentation. The factor theorem connects factors to roots of polynomials. It helps factorize polynomials and find the solution to equations. Thank you for listening to my presentation. I hope my presentation on factor theorem really helped you guys out, and hope this will help you out solve all your equations. Have a great day.